The first question here, we have find the gradient of the curve y is equal to x to the power 3 minus 2x to the power 2 plus 1 at the point where x is equal to 2. If we draw a curve on the graph, we have y to be on the x-axis and x to be on the x-axis here, this horizontal axis, sorry. If we have a curve, we have to find the gradient of this curve. We're going to draw a tangent to this curve, and then we take our gradient or slope of the curve. We'll trace this point of this gradient or this slope to a value on the y-axis, and we'll trace this point of this curve to a value on the y-axis also. This point will correspond to a value of x here on the x-axis, y here will correspond to a value of x here on the x-axis. To find the slope is the change in the y-axis all over the change in the x-axis. So slope is change in the y-axis over the change in the x-axis, and that is y here minus y subscript 1 minus y subscript 1 divided by x here minus x subscript 1. And if there is this is our slope of our graph. But if there's an instantaneous change on the y-axis, if there's a change on the y-axis, it will also give us a change on the x-axis. And from first principle, we show that this change, if we limit h to 0 from first principle, this change will tend towards the derivative of y with respect to x. So slope is nothing but the differentiation of the equation that gave birth to the curve. So we just show that the gradient is the same thing as the slope of the graph, and that is derivative of the equation that gave birth to the graph, or that produced the graph. Now, in that case, from our question here, we are told that find the gradient of the curve y is equal to x to the power 3 minus 2x to the power 2 plus 1 at the point where x is equal to 2. So I'm going to find the gradient of this curve, which is the derivative of this curve. Then we'll substitute the value of x, which is 2, to replace x in our gradient equation and find the value of the gradient at that point. So to find the gradient of this curve, we'll find the derivative of the curve. Question 1. So we'll find dy dx of this equation. And that gives us 3x raised to the power 3 minus 1 minus 2 multiply 2 here to give you 4x raised to the power 2 minus 1. The derivative of constant here is going to be 0. So our equation is 3x to the power 2 minus 4x. This is our gradient, dy dx. Now we are told that at this point of this gradient, x is equal to 2. Find the actual value of the gradient. So we substitute x as 2 in this equation. So from there, dy dx will be equal to 3 bracket 2 to the power 2 minus 4 bracket 2. That gives us 2 to the power 2 is going to give us 4. 4 times 3 is 12 minus 4 times 2 is 8. 12 minus 8 that will give us 4. So dy dx is equal to 4. In question 2 here, let's take this away from the screen. In question 2, we have a function is given as g of x to be equal to as to the power 3 plus 4s to the power 2 minus 2. Find a if the g form of x, the g form of 3 is equal to 10. Now the g form of x here, we're going to find the g form of x, which is g form of x, the g form of x, and that is simply the derivative of this equation, and that will give us 3a s to the power 3 minus 1 plus 8x to the power 2 minus 1 minus 0. We simplify that, that gives us 3a s to the power 2 plus 8x to the power 1. So that's what we have as the equation of the g form of x. Now, the g form of 3 is 10. So to find the g form of 3 to 10, We're going to substitute the value of 3 here. We'll replace the value of x here, we'll replace it with 3 and equate our derivative to 10. So we'll substitute 3 into our to replace x here and then equate this equation to 10. So if you do that, the g form of 3 is going to result to 3a bracket 3 to power 2 plus 8 bracket 3. We equate that to 10 from this question here. 10. So we'll have 3a bracket 9 plus 8 times 12, that is 24, to be equal to 10. 3 times 9, that's 27a, plus 24 is equal to 10. So if we take this across, this positive operation becomes negative. We'll have 27a to be equal to 10 minus 24. 27a is equal to minus 14. Dividing both sides by 8 to remove by 27 to remove a from there, have 27a divided by 27 to be equal to minus 14 divided by 27. From there you have a to be equal to minus 14 divided by 27.